Hello learners, this is my new course on Terraform related to Terraform Backend. Prerequisite for this course, fundamental knowledge of Terraform is required. Please check out my previous video related to Terraform getting started to understand all fundamentals which is required for this course. Let's get started. Since we know that Terraform always keeps the state of infrastructure which is maintained by it, a backend defines where the Terraform stores its state data files. Terraform uses persistent state data to keep track of the resource it manages. In my last course, we have seen only local backend. That means the state file was created in the local file system, as you can see here. So we have our Terraform files, which is .tf files. And once we will do our resource deployment using Terraform plan and Terraform apply, the state file has been created, and this state file is created in the local file system. So this is our local file system, LFS. Now, what about the remote backend? So in the remote backend, this state file, which is earlier here, is moved to some remote location. So that means this state file will not be part of our local file system. Terraform allow us to create this backend remotely. This lets multiple people access the state file. So if you can see here, now this state file is somewhere else in the remote location, which is shared with all the users. So now all the users can access, who is allowed to use, they can access the state file together and work on it, this collection of the infrastructure resources. So now what are the possible state backend Terraform offers? So we can use storage account, S3 bucket, Google Cloud, etc. We can have these options here which we can use to create our backend where somewhere in the remote location. Now what I'm going to show in this video, it is related to Azure RM, where I'm going to use Azure storage account to save my all my files, state files over there. So this is Azure backend, and now I will show you 6 ways of authentication, where first is Azure Key. And in Azure Key we will you know that we have this Azure Key binary which we use to authenticate, and then use the authentication to create the backend and save my state file to storage account. Then we have this initialization backend config variables which we can use to provide on runtime about my configuration information. Then we can use storage account keys, SAS token. Then we have service principal. And from my past experience, I will let you know production ready configuration which you can use in your project, and it is more recommended way of using backend configuration. So let's move to demo so that we can understand it properly. So it is LFS, local file system, and in the LFS I will create main.go, and here we can define some parameters here. So for example, I am trying to first I have to define the Terraform block, and then what are the plugins I have to use, etc. So for that, let me just have this ready here so you don't have to waste your time. So we have this, no, not go, it should be tf. So it's tf file. So we have this Terraform block here, and we have resource providers, and we have this backend Azure RM ready, and then we have this Azure RM. I'm using this provider called Azure RM, and here I am, you see I am using a backend, but this is LFS, so I am just removing this part from here and try to run my terminal. And here I have to go to LFS first, and I right now I'm not login to anywhere, so I have to log in as well. AZ login. So I have popped up on another browser. Let me log in quickly. So I'm logged in now. Let me clear it. So if I run my, but I haven't created any resource, so let me create some resource also. So let me create one resource quickly. So resource Azure RM underscore resource. So scope. So resource group, I'm just creating one small RG just for demo. Name equals to something like demo RG. Let me make it demo 1, and the location will be West Europe. Let me save it quickly and run Terraform init. So what it is going to do when I run Terraform init, you see it has initialized my package, it's initialized my Terraform file, Terraform project. And if I run Terraform plan, then it is creating TF state here in the locally over here, you can see. So this is not the target scenario for this course. We are going to create Terraform state by using Terraform backends on the remote location. So this is the normal scenario which we already discussed in our previous course. So we don't have to discuss this one. Let me create a new folder here and let's make it like a CLI. So we can use CLI for our backend definition. We will define some parameter for the backend and then we use CLI to authenticate ourselves and create our backend at storage account. So let me try to just copy this main folder and put main file over here. And in this main file, as you can see, I haven't defined any backend here. So let's define backend quickly. So it should be like backend, and here which type of backend. So you can see here Azure RM, console, COS, Google Cloud, HTTP, Kubernetes, local, OSS. We have so many options, but I'm going to choose Azure RM here. Here we have to give information about our storage account and the resource group and where this storage account is there. So what we have to do, we just go quickly on our browser. So let me go here and Azure portal, and let's create a storage account. So resource group, let me create a resource group quickly. So let me create something like backend demo RZ, and location will be West Europe, sorry, and review and create. Now we have this over here. Now we can create one storage account quickly here. So let me search storage account, create, and we selected backend demo RG, storage account some STAZ state, some random variable. So we will use this one, West Europe standard, everything. I don't want GRS, LRS is okay, advanced everything is fine. I don't want hierarchical namespace. Networking, I want public access to be enabled here, and data protection, encryption, tags, everything is fine. Let's create it. Okay, so our storage account got created, and let's create a container here for our TF state. I'm just keeping TF state just to understand, but you can keep any name for the container. That's totally fine. So container has been created and we are good to go now. So let's go back to our Visual Studio Code, and here we already mentioned about the backend. Now we have to provide information about the storage account. So what information we require? We require to mention about the resource group name. We require to mention about the storage account name, and we require container name where it is getting created. We will get all this information from Azure, that's not a problem. And then the key, but key is not like it's in Azure, we can create name here as well. So I'm just keeping it something like CLI dot tf state. So we will understand that this tf state has been created by the CLI. And let me quickly fill up all this information. So I have filled this information is resource group name, storage account name, and then container name is tf state, and then I am writing this key cli.tf state. This is the file which is getting created with this name. And now I just save it and let me try to initialize it. So I am in LFS, so we have to move out from LFS and then let's go to CLI and then Terraform init. Okay, so Terraform init initializing the backend, successfully configure the backend Azure RM. The message is RM Terraform will automatically use this backend unless the backend configuration changes. So unless I am working in this folder, so automatically my project will always use this Azure RM backend, which is I mentioned over here. Until I will reconfigure my backend, it will use the same. Let's verify it. So I have this backend here and this container here. Let me go inside and you can see new file has been created as cli.tf state. So this is how we can configure the backend using our CLI commands. Now let's go for the next option which I mentioned, which is init configuration. So let me write init config. So we can also mention the parameters in the init command and then we can use it. So right now I'm using this one, but in next one I'm not using these information. I'm just using this one. Copy, and over here let me create one main.tf file and just paste my information from the LFS. So here you see I haven't mentioned anything. I just mentioned here that it is going to use backend Azure RM, and that's all it is going to use. And now for running this command, what we have to do, we have to inform everything to my code, to my project in the init command. So let me do back and then go to cd init. So I'm here, and how we can write that command. Now if I run terraform init, if I hit enter here, it will use the default it will not use the correct backend. So if I enter here, it will run as an error that I'm not providing all the information. So see, it's asking for the container name or all those information. So let's cross it and clear. So let me go and write down the command here, terraform init. Here I will use backend -config, and in the backend config I have to define everything as a key values. So first is the key, another one is the value. So for example, whatever I have defined in this block, this will come as a key value. So I am defining as a key value. So this is our key, and then value will be this right hand side is the value over here. This is beneficial when we are running some automation and we have to define something on the runtime and we don't have to define in the code, then we can use this. This is also good. Now then another backend hyphen config, and this equals to storage account name, so in this one let me give this name not CLI, it's init dot tf state. So let's make it init.tf state as a key. So file will be created with init.tf state. So I have completed my command and I will just hit enter here, and now you can see it is initializing my code here in this init config folder, and Terraform has successfully initialized. Let's confirm from portal. Here you can see my init.tf state has been created. So this is the second method we can use. Now the third method is storage account keys. So again let's do one thing. Let's close this one, this one, and we create one more folder here, stz keys, and let me take everything from here so we don't have to write code again and again. And now we have to define the storage account keys over here. So for storage account keys, again what we have to do here, we have to define the backend first, backend Azure RM, and we have to define the remaining part as well. So let me go here and just copy quickly. These four properties is required to be part of this backend. And now what else is required? Now we require the access key of the storage account. So here we need to provide the access key. Let's go to Azure storage account, and in this left blade we can see access keys here. So I can copy this access key, don't worry, till the time you will see this video this storage account will be gone, and I will save it. And since I have saved it over there, and now if I go to cd.bank and go to storage keys folder, and now if we try to initialize this, then it will use storage account keys for accessing the storage account and then create the target TF state. So I will change it with the keys S or stz keys dot tf state, and then I will initialize it. Now I haven't mentioned anything here, so it is going to use my CLI but for creation of the resources, but for backend it will use this access keys. It will not use my CLI here. So let me initialize it. Successfully initialized. Let's confirm from the portal. TF state container, refresh, and you can see stgkeys.tf state file is created here. So this is our third option for authentication. Now let's go for the fourth method, which is SAS token. So it's almost similar to like this, how we have authenticated the storage account. The only change will be, instead of using access keys, we will use authentication token. So we will remove this part from our backend, and then here we will say we will give access token. Let's create an access token quickly for the storage account. Going to the storage account, the left blade, you can see shared access signature. I don't want file, queue and table. Yes, I want these resources to be created, and I don't want immutable, permanent. I want list, add, create, delete. It's up to you, but I am just removing it. Enable deletion for the versions, that's fine. And now I am just creating it for today, and basic authentication, HTTPS, that's fine. Create the SAS token. So this is the SAS token we have, and let's save the SAS token over here. So now SAS token has been given, and let's create the key, which is SAS token TF state. And let me clear this screen, and now we are in the stg key. So let me go to the SAS token folder and run Terraform init. Good. So initializing the backend, it's successful, and Terraform has been successfully initialized. Let's confirm from the portal. Go to the storage account, and then containers, STF state, and here you can see SAS token.tf state is created with the help of the SAS token authorization. So we have completed our 4 authentication methods. Let's go to the 5th one, which is little bit complicated. So bear with me, you should have a little bit knowledge about Azure, then you will understand this perfectly fine. So it is SPN, service principal, and in this one, service principal, we will just copy all this from here. In the SPN, we will create one file, main.tf, and let's put everything here what is we defined earlier, and we will just make it clear. So we don't require this SAS token now. What we require here is we require client ID, we require client ID, and with the client ID we want client secret. I'm not showing you certificate for in this course. If you want, you can just comment that you want a video on certificate. I will show that as well, but in this section, in this video, I'm just considering client ID and client secret. And with this client ID client secret, we require to tell our backend configuration that what is the subscription and what is the tenant this client from. So subscription ID we have to mention here, and also the tenant. Now before going fill up this value, we need to create a service principal in our portal. So let's go here, search for AAD. No, sorry, not AAD, app registration. So we require to create an app registration, and here we are going to create a new Terraform underscore app. So we are creating this app which is called Terraform app. This is going to create a new service principal. It's created, and in the secrets we are going to create a new secret here. So secret for TF, and now let's copy this value from here, otherwise it will be gone. Let's go to our code. Here I have put my client secret, and for client ID, remember this is very important. In the client ID you can mistake from this object ID. Object ID is not a client ID. Client ID is the application ID. You can see here it is mentioned also, application bracket client ID. So we have to use this client ID or application ID as a client underscore ID over here and save it. So now in the service principal, I have mentioned my client ID, my client secret, subscription ID, and tenant ID. This is not enough right now because you have created a brand new service principal, and now you are going to use this service principal to create some file in our storage account. So two permissions required for this service principal to create to initialize our project. What two permission is required? Let me show you. So let's go to the storage account, this one. So the first permission which is required, I will show you by making an error. So first permission is required to have storage blob owner. So this is Terraform. Terraform always want this least permission storage blob data owner to be part of the service principal which we are going to use for initializing our backend. So this is, we are going permission to our app which is service principal and select review and assign. So according to Terraform, we have given enough permission and now our code should run. Let me try quickly. CD and then go to SPN. But it will fail. That I am telling you, it will fail, and I will show you why. So Terraform init, it's failed. And now if you read here, failed to get existing workspaces, error retrieving keys for storage account, which is this one. So it is trying to retrieve the keys for the storage account, but it is not authorized. Failure responding the request 403 unauthorized error. So our client, which is our application which we have created or also called as service principal, does not have authorization to perform Microsoft storage account, list keys and action. Our service principal does not have this permission. Microsoft storage account, list keys, action, and because it is not having this permission on our storage account, it's failing. Now we have to give, either we will create a custom role to assign particularly this permission, which is little bit more complex. What I'm going to do, I'm going to give owner access to my service principal. So you will not find owner access over here because it's a privilege role. So you can find those privilege roles in the privilege administrator roles. So I'm giving owner role to my service principal here. Let me select my service principal, Terraform app, and provide this permission. Permission has been granted, and since permission is right now granted, it's in Azure, I have seen it, it will take some time for this permission to reflect or synchronize. So sometimes if you have given permission to any service principal, you have to wait for like 30 seconds or 20 seconds or sometimes 1 minute as well to get this permission effective. So if I run it right now, it can be possible it fail if the permission is not synchronized. If the permission is synchronized, it should run. Let's see, initializing the backend successfully configured. So that means the permission has been given and it is synchronized and granted. So now you can see Terraform has successfully initialized, but the problem is we have used the SAS token. So this small mistake we have done, that we have used the previous SAS token, so we cannot see any new. So let me go to the containers. So we cannot see the new file over here. So we are not seeing new file. So what we are going to do, it's a good that I have done this mistake here. We can learn something new, more new over here. So what we are going to do, we are going to change this to spn.tf state. Now let's try Terraform init, and let me tell you guys, it will fail. It failed because I am changing the backend configuration. And if I want to change any backend configuration, either I have to use the migrate state. I don't want to migrate my state because it's a fresh new project, or you can use reconfigure. Okay, that's fine. I can use reconfigure. So let's try to write Terraform init, and let's go with reconfigure. And since I'm reconfiguring my TF state, so what it is going to do, it will not touch the old state file. It will remain like that, and it is just going to create a new state file from our project. So we can confirm this one from here. So here you can see this new spn.tf state file has been created successfully. So now the last one, that how our production should look like. So for production, let me write like prod, and let me just copy everything from here and create a file main.tf, put everything here. So now how our production should look like. In our production, if we share this information, client id, client secret, etc, etc, it's not good. What we can do, we should just remove all this information from here and use environment variables. By using environment variables, we don't have to define anything over here. So let me just go to this folder quickly, cd prod Terraform fmt, just to synchronize, looking good now. And we will remove all this information from here. So how we are going to remove, and which environment we will create it, we can search over here, Terraform environment variables. You can search Terraform environment variables, and over here I can see, no, not this one. Let me check the URL. So this is the correct URL. I can share this URL in description. So if I want to use service principal with the secret, how we can do it. So service principal with the secret, these are the things which we will define. So what I'm going to do, I'm going to make the environment variables for these, and let me go down a little bit. So these are the name of the environment variables, that ARM client ID, ARM client secret, tenant ID, etc. So let's start from this one, environment variables. Let me share with this view. Let me go create this client ID, remove this extra space, and go to this code, and the client ID is this. Over here, okay, that we have mentioned ARM client ID, ARM client secret, subscription ID, and the tenant ID over here. So now we can use these value over here, or if we want, we can remove this value as well. And now in the production, our code is totally free from any information related to our Azure RM. But now how we are going to run it? So for running this code, what we are going to do, we are going to use our Terraform init with configuration. So let me just search the old command, this one, and here I'm just going to change this key to prod.tf state. So now in this, I'm not mentioning anything related to my client secret, related to my client ID, subscription, or anything else. And in the code also, I'm not mentioning any information related to my backend. So I'm securing my code from any kind of sensitive information, and this is the best way to deploy our code in the production. Let me just hit enter. It runs successfully. And now let's go to our storage account. Storage account here. Let me refresh it. And we can see the prod.tf state has been created successfully. So this is how we can create, authenticate our code, our project, to create the tf state file in the remote location. And I have showed you 6 ideas or 6 ways to authenticate, and I already showed you about my best idea or best method to authenticate, which is I have created in the production. Thank you so much for watching.